Okay, everyone, we'll get started. We're already live, so I'm just going to start talking. So first of all, thank you all for joining us on this special event, right? We're here on a Wednesday because we have a guest speaker, Dr. Ioulia Kovelman, joining us from the University of Michigan. Dr. Kovelman is actually attending a conference. What's the name of the conference?
International Dyslexia Association.
International Dyslexia Association, and he happily agreed to give a presentation to our center as a part of visiting Dallas. So just a little bit of background. So Ioulia, or Dr. Kovelman, graduated from Dartmouth College in 2006 with her PhD in cognitive neuroscience. Actually, the reason I know her and I know her so well is because we were actually grad students together at Dartmouth. So we've been longtime friends, academic friends, and friends in general. Before I go on with her biography, I'll tell you one quick story that I tell my class when I'm teaching about language development. Because Ioulia worked with Laura Ann Petito in a language development lab while at Dartmouth. And when Ioulia started, she was Laura Ann's first grad student. So they built out their lab, they had to paint it and do all these things. And it took them a long time. And it was a really different lab for the department because they were bringing in infants and kids to study language acquisition. So I remember it was like pink, I think, right? And there's like toys everywhere. It's not typical. Obviously now we have development labs in the center too. But when it was finally like open, Ioulia and Laura Ann were like, "Oh, do you want to see the lab?" I'm like, "Oh, sure." So we walk through the lab. And they're pointing out these paintings. I don't know if you remember. There's paintings on the wall. And they were like very proud of the paintings, right? And they were like kind of watercolor or just like, there's general paint. And, I have kids, right? I have a 2-year-old, a 4-year-old, a 7-year-old. And I know kids don't paint really great, but these paintings were horrible. And they were so proud of them. And I was like, what do I say? It's just awkward, right? So we just keep walking. I'm like, oh yeah, great paintings. And they're like pointing out all this artwork. Like it's framed really nicely. And I had no idea until later. I was like, Ioulia, great lab, but what's up with this art? And it turns out that, when Laura Ann was a graduate student, she worked on this project called Project NIM, which was a study of trying to teach a chimpanzee sign language, which was conducted by Herb Terrace in the 70s at Columbia. And as a part of that, NIM would paint. So Laura Ann Hall had all those paintings and she put them up. So it wasn't like a child's painting, it was a bunch of chimpanzee paintings. But I tell my students that story. It was always really funny to me that, I was clueless for a while about why we were staring at this artwork for so long. Okay, following Dartmouth College, Ioulia moved on to MIT to complete postdoctoral training at MIT with John Gabrielli. And she arrived at the University of Michigan in 2009, and she's been there since then. She's now a full professor. She's a developmental cognitive neuroscientist, studying literacy development in children who speak English and other languages. We'll get to see some of that today. But she uses a combination of FNIRS and innovative behavioral techniques and analyses to study typically developing readers and at-risk learners, such as those with dyslexia and developmental language disorders. So I'm excited I get to hear about all the exciting things she's been doing. And I thank you all for joining us, but please join me in welcoming Dr. Kovelman.
Thank you, Doug, for warm words. And thank you all for coming here on a Wednesday afternoon. It's lovely to see familiar faces that should have been familiar. They will be familiar soon. It truly is delightful. The only thing I have to say, and it is kind of related to my talk, is that, Gagan was my baby classmate. He was the youngest person in our cohort, and she's all grown up now. Which puts me out of the discussion on how old I am. And what I really do want to do today is, obviously, I'll talk to you about science and show some brain pictures. I think we've been promised some brain pictures. But that is not the purpose of the presentation at all. Rather, it's to talk to you about the science and the people who are in it, the kinds of questions we ask as we go through life. Now that my baby classmate is all grown up, I feel like I now can truly talk about the field and the way we've gone about it. So when you learn to read, you may have expected that the brain changed. If you want to know more about it, you guys are doing aging, right? Lots of development. International Dyslexia Association is going to be somewhere around here. I don't know. This is my first time in Dallas. I was a huge fan of the Dallas show. I can tell you all about the story. I was a teenager, everything collapsed, and then this was like the first thing we saw. So I thought the whole of the United States looked like Dallas. It's a show. For those of you who are too young to know what this is, please just discuss. There's some age differences in the group. On I go. So we think, well, some sophisticated colleague of ours, Ken Pugh and others, have looked at folks reading in languages like Spanish, English, Hebrew, and Chinese. And since you guys are neuroscientists, right? So the blue is the print, and green is the language, spoken language, and purple is the overlap. And you can really tell which is which in terms of which is language is which, and it all kind of looks very similar. And the big story here is that the purple is the overlap between the spoken language and the print. We read to see language, right? That's the purpose of the reading, and it's universal. Speaking of Niemczewski project, my PhD advisor on NPT studied universality of language. And so this fits with the story. Language is universal, and even though Chinese characters don't look like English alphabet, nevertheless, our brains are built universally. We are all trying to access language. At the same time, you don't need to be a neuroscientist to tell me that these two pictures are not the same, right? You don't need to be. Some of you, I think, I hear here, you have PhD and have even completing postdocs in neuroscience, but these are not the same. And what these are is these are folks who are doing a rhyme judgment. It's a comparison between native speakers of Chinese and native speakers of English, and they're clearly not doing the same thing. How come? How come? Right? I just showed you this. So is it about language, right? Is it about language or linguistic structure? There begins the question. So when I give this talk, when I give talks in China, and I ask people whether they would like to switch to Cyrillic Russian alphabet, it's very seldom to let it consistent. Thank God for the communist revolution. It revamped the alphabet from the archaic system, which you guys are still wedded to from Shakespeare days. We now have a very good alphabet. Nobody wants to do it, like never any takers. And then again here, I rarely get folks to volunteer to accept Chinese characters as their regular literacy. We feel really wedded to it. And for those of you who are old as me, you might remember Nokia. Do you remember Nokia? They were made in China, and I, of course, encountered them first when I was in Russia, and then I went to Israel, and then I finally wound up in Canada. And guess what? We were all using it in the English, right, lettering, no matter what your language was. Oh, we all made it. I mean, of course, as it switched now with all the iPhones and such, we do it, but we all could kind of deal. And it kind of makes sense because, you know, orthographies are not optimal, but we think they're good enough, right? So we have an Egyptian symbol for these are Semitic languages, right? So we got from an ox progressively to, you know, through the Greek and Phoenician alphabets, we got eventually to letter A. So all of us, regardless of whether you use an alphabetic system or character-based system or anything else in between, we all started with pictures. And then eventually these pictograms became progressively more symbolic to arrive at the symbolic system that we use day in, day out across the globe today. And we think they have something to do with the language, the underlying language structure, because we stopped at different points in the development of these systems. So the way I look at this question is through bilingual heritage language development. Texas is actually unique. You have a lot of Spanish and Vietnamese speakers, and you have a lot of bilingual schools, but in most places we don't. Welcome to Michigan. It's really is Anglo land, and most kids speak and learn to read in English, regardless of what language they speak at home. So if it was just culture, then the language that the kids speak at home, and rarely read actually, should have no impact on how they read in English. If language structure, even a spoken language structure, has something to do with that, then we should see the signs of that in the way they're learning to read in English. So a couple of things about reading. The reading system, this is very simplified, but essentially we think if you know what a word cat is, and you know what it sounds like, and you know what it means, you can then figure out the cat, how to spell it, right? And so this is the sound system, K-A-T, and this is the meaning system, there, and there. They sound the same, they read differently because that's how we got here, right? And you just need to know the orthographic forms. For the alphabet readers, we're right here. We really need that sound to letter correspondence. So this is a rhyme judgment task is the first way that we try to get into the mechanism that underlie this phonetic system. So we get children age 4 or so, and we ask them to come and have rhyme. And if this pre-literate 4-year-old child does well on this task, they will be a good reader at about grade 2 and 3. If the child at age 4 cannot do the task, it's a red flag. They're headed for dyslexia or reading disability by the time they hit 2nd grade. So this kind of task explains up to 50% variance in reading performance by the time kids hit elementary school. So it's really powerful. And with John Gabriel at MIT, we would get the kids, stick them in the scanner, give them the rhyme judgment task. And this is from John Gabriel, he's my postdoc advisor at MIT. They got this data at Stanford, but that's irrelevant. So they asked the kids with and without dyslexia to do a rhyme judgment task, just like what I'm showing you. And what they get is the typically developing kids, the activation Broca's there and Vernon kids there. Here, I'm preparing to talk to teachers. Never mind, I'll be gesturing a lot about brain structures. And then the kids with dyslexia do not engage these canonical language regions. And as I told you before, there's a volume of knowledge that we have about this. Phonological awareness is impaired in dyslexia. The language regions are less active in kids with dyslexia when you give them this kind of task. And then that made a lot of sense, right? That makes a lot of sense because if you think about this, right, Lauren Petito, my PhD advisor's work focused on the universality of language. And as I was transitioning to MIT to Dartmouth, she was publishing work showing that babbling is universal. Deaf babies never exposed to a spoken language will babble on their hands. These are syllabic units, right? So these are meaningless syllabic units that adults don't produce, but children do. We think it's a universal milestone to language acquisition. And then at the same time, she was publishing work looking at deaf and hearing adults. Sorry, it doesn't matter if you're deaf or hearing, whether you did or did not use sign language. And so signers would activate the canonical language regions, right? Again, the STG, when completing phonological tasks in sign. And of course, hearing individual would show activations in gesturing parts of the brain and motor cortex, but not this, right? So the universality of things makes a lot of sense. What makes most sense is the phonology, right? So if you think about this, the phonology, the babbling milestone is a gateway to language. Clearly, breaking words into sounds is a gateway to learning how to read. And STG is important, right? It processes sound, and it doesn't work so well in kids with dyslexia. There's nothing else to do. We're done. We can go home, right? So another piece from a colleague from my MIT days is Fumiko Hep, who is now at UConn and Yale. So she was looking also at kids with dyslexia. And what she did is she identified a set of regions in the frontal and parietal temporal lobes that are, again, not as active in kids with dyslexia, and also had lower gray matter volume. So this all makes sense, right? This is it. And this would have been the end of the talk, except that people started publishing this kind of stuff. This came from Hong Kong. So Siok and her colleague Chuck Perfetti went to Hong Kong. They got 10-year-old Chinese-speaking children. They gave them a rhyme judgment task. They put them into fMRI. They looked at the same brain regions that Fumiko Hef was looking at, and they got no differences. And then a couple of years later, I met Chuck Perfetti, and I said, what was that? And he said, I don't know. We just published it so that you could ask the question. I was like, well, thanks so much. And I came from a deep, deep universality laboratory, right? My PhD advisor was looking at primates, never mind sign languages. Like, this is not possible. Somebody got something wrong, was my first gut reaction to it. And take a look, but then take a look. I mean, evidence hits you in the face at some point. Phonological awareness predicts 20% of reading acquisition from our own lab at this point, 20% of reading acquisition in elementary school. And it's barely at like 2% for kids in China, right? There's our colleagues in Cheng. And then there's a lovely colleague. This is how I got to Texas about 10 years ago now. I know this guy, James Booth. I said, James, you're the only person looking at Chinese brain data. Can I look at it with you? And so he was looking, he and his graduate student, Fan Chao, who's now, who's a terrific researcher and is back in China now. So she looked at Chinese adults and Chinese children. This is STG. There's no difference, right? And only the English-speaking adults show greater activation than the kids. So there's a developmental increase, but only in English, right? So there's accumulating evidence that was in deep contradiction with my, I don't want to call them religious language, but formal language there. Again, my PhD advisor is my hardcore, and this wasn't making any sense. Yeah.
But these are all reading tasks, right?
This is actually auditory rhyme judgment task. In this case, they did an auditory rhyme judgment task. But yes, it's reading for Siok. It is reading for Siok, and it is auditory for the Booth study. And that's how I came to Austin. I contacted James Booth because I couldn't make sense. And so he got me a fellowship, and I got to hang out with him. And so what people also did is they introduced me with Cammie McBride, who, along with Ioulia and others in China, was publishing these papers are coming out showing that phonology doesn't predict reading development in dyslexia. It really doesn't. And I'm not just seeing stars, in front of my face on this. It has something to do with morphological awareness. So anybody who speaks Chinese natively in this room, maybe, would you mind reading the two words?
Chinese?
Yes.
The first one is 苹果树. Second one is 面包树.
Thank you so much. So the task that would be going along with these words is apple trees grow apples, right? This is the 苹果树. Sorry, I apologize. My pronunciation is terrible. And what kind of trees would grow bread? Bread trees. Obviously, you didn't know. This is called morphological awareness, right? You're taking the word and you're also segmenting it, but you're segmenting it into the smallest units of meaning. So that's the task you give to a 4-year-old in Beijing to see how they will read in 2nd grade. This is the task that will predict you 20% of reading variance in grade 2 and will predict whether or not the child who's a native speaker of Chinese will go on to have dyslexia, right? So it's not a phonological rhyme judgment task. It's the morphological task, and it makes sense, right? Because you can see, and I will, right? So you can see that the shoe corresponds, right? So it makes it, but it's not a sound. It's a full morphosyllable. So you're mapping not the sounds to letter map. It's not the og, right? The way we do it in English. It's a morphosyllable here that maps onto the entire character. And so now the data taken together is beginning to make more sense. Phonology still goes on to predict about 20%. And it's about 5% for the morphology in Chinese. I'll show you that in a more detail. But here it is. Here's morphological awareness, this kind of apple tree, bread tree task. And that's what's predicting the 20% variance in the kids who are learning to read in Chinese. All right. So now we can roll up our sleeves finally and begin to ask questions. Does language matter in how you learn to read? And if it does, is it going to spill over to how these kids are learning to read in English? And so we're looking at phonological awareness across alphabetic languages and morphology across across alphabetic and other languages, but with keeping in mind that this might matter differently across. When I got onto this train, we knew a ton about phonological awareness, this stepping stone, all the things we just discussed, stepping stone to alphabetic orthographies. You can, if you know nothing about morphological awareness, you go onto Google and you say, buy phonological awareness task, and there'll be no limit to the search. You can purchase them off the shelf, standardized for any age range, super easy. We know transfers in bilinguals because it's just a sound segmentation. You could do for any word. We know it's impaired in dyslexia, and we know the neural organization for it. I've shown it to you. And for morphology, well, we knew it was a stepping stone to Chinese, but then it wasn't quite as clear whether it transfers cross-linguistically, because what you have just heard your colleagues say in Chinese, right, the way these characters and syllables align, you really need to know the language, the way this is going to line up. You could not go on Google and purchase one off the shelf that would be standardized. It still isn't possible. You'd have to call me or a couple of my colleagues' labs, and we will kindly share. But that's as far as you're going to get. And then we don't really know how well it transfers. And then we're hitting dyslexia and neural organization. Now, morphology is lovely stuff. It's not the stuff from the linguistics textbooks, I promise you, right? You use it all the time. The word like contactless appeared in this aggressive form of usage during the pandemic, right? All of a sudden, everything became contactless. Everybody knows what it means now. But this is the living, breathing blood of the language, right? This is why we don't inherit language from our parents. We have to make it. We make new words. Morphology is that vehicle by which we make new words. It takes a while to develop. We've known for a while that here's a wog. Now there's two of them. We have two wogs. And preschoolers can do it really well. And this is grammatical morphology. And here's lexical morphology. I had a grad student, and her younger brother didn't know how mustache. It's a complex sort of mustache, and nobody in this, I mean, few people in this room will have it, right? It's kind of not a thing anymore, and he wasn't sure what the word was, and so it's like nose bangs, right? I mean, you get it. It's obvious. If you're gonna go on, but this is morphological, right? We have to think about this as a competence. So the next step is how would you measure it, right? I send you to a room full of kindergartners. How would you measure it? Here's one way of measuring. So classroom, mushroom, bedroom. Which one doesn't belong? Sure. Mushroom doesn't have a room in it, right? It's confusing. And then when kids get a little older, we do something like this. Sidewalk. Use this word to complete the sentence. The baby's learning how to walk. Foggy. On some mornings, you can see fog. Election. How many women did they elect, right? And so we actually had to make this task. These tasks were available for late elementary and middle school kids. And remember I told you in China, these kinds of tasks predict the preschool level. So we had to really work with these measures to bring them down in age, and so that they would have also structures that match Chinese, right? Compounds, which is two roots put together. English, this is English morphology. And we also look at Spanish bilingual, so we had to have these. They're later emergent. These are Latin based, right? Okay. But the first thing we discovered along the journey is that morphology does matter, right? So folks had thought that this is mostly a middle school thing, and so now, and it's not just our lab, there's sort of been a momentum of morphology in the field in the last decade, saying, look, it does matter. It emerges. This is kindergarten to grade 2 or 3. It matters. It produces about 4.5% or 5% variance. It's lexical, not grammatical morphology, for those of us who care about language structure. And both compound and derived matter. Why does this stuff matter, you may want to ask? The reason it matters is a morphological awareness buys you reading comprehension, right? So the ultimate goal is, of course, not to read words, but rather to read entire text. So you're faced with words and sentences. You have to make sense of things. If you've never heard the word nose bangs before, but I give it to you, you can reason yourselves. If you understand morphology, you can get yourself there. So this is a study by colleagues of ours. So they were looking, they actually did a morphological intervention with good and poor readers. And they showed that the good readers didn't actually quite change much, but it was the poor readers that made massive gains. And it's like you give them a tool. Because poor readers do a lot of things. They don't know vocabulary. Sometimes there's lots of things that go on. But here you give them a tool for segmenting words, and all of a sudden they can read nose bangs, right? Even though they don't know what it was. So this is where we get to a point where we can say, okay, so morphology is about recognizing new words, contributes to reading. That's really early for reading and comprehension. And so now we move on, and we're ready to ask our first question. First question. Do bilinguals develop language-specific literacy networks? And we're right, so we're getting back to the beginning and talking about Chinese-English bilinguals and how it might develop in Chinese and in English. And in this particular study, this is my colleague's daughter, my student's daughter. She's lovely. Anyway, so what we did is we had Chinese-English bilingual kids in Ann Arbor, Michigan. We were recruiting from the local heritage language school. So this means these kids got about 2 hours of Chinese instruction per week at the most. And their character reading proficiency for most of them did not reach kindergarten levels. for what our colleagues in China and Taiwan were showing. So this is a really low word reading proficiency, but they are attending a school and they're getting regular instruction, and their parents, usually both parents, are Chinese. And we had them compared to the proficiency in age-matched English monolinguals. The reason their proficiency matches, we're looking at early bilingual. So there's different populations that can look at. Most of these kids got English before they were 3. And we're in neuroimaging lab, so we gave them an FNIRS task. During that task, we gave them 3 words. It's an auditory task. We prepared them with pictures, and then it's finally just auditory. And they hear 3 words. Cat, king, puppy, which one has the same starting sound? Kitten and king start with the same starting sound. And puppy is a semantic distractor. And then the next task does the opposite. Classroom, bedroom, mushroom. So bedroom and classroom have a room, and mushroom is a phonological distractor. So that's the task. Here it is in Chinese, in case you're Chinese and would like to see it. And here's a quick video. This is a video we use for recruitment. Those on Zoom cannot hear it, and that's okay. I just wanted you to see our lab setup.
We study how children learn to read and how their minds and brains.
This is a commercially thing to attract the parents. So, but we'll see in a moment our lab setup.
Instruction to help children become better readers. During the visit,
So this is our lab.
survey about their child. Children play reading games and learn about science and how their brain works.
PPVT, if you haven't seen
How
one.
children's
And here's our FNIR setup.
safe and child-friendly FNIRS method. Using sensors similar to those in everyday smartwatches, FNIRS measures changes in how the body and brain work. Participants are paid for their time and receive information about their children's learning. Our project directors are
All right, so FNIRS neuroimaging. There are multiple reasons for using this technology. Mine was sheer stupidity. Sorry, Gagan. So I did fMRI for my postdoc. I did use both technology as a graduate student with Gagan. And then my postdoc was all fMRI with John Gabriel at MIT. And I was coming to University of Michigan, and the FNIR systems were actually the size of a startup at the cost back in the day. They were like, either your whole startup goes to the purchase of the FNIR system, or you can actually use MRI scanning times, hire a postdoc, and do other things with it. And I was like, oh, sure, I can use fMRI. I mean, the CO can perfectly scan these kids in Hong Kong. Shouldn't be a problem. Anyhow, 150 participants later, of Chinese-speaking participants later, of which only 15 agreed to undergo fMRI scanner, all of which were from Taiwan. And I come from former Soviet Union, so I kind of get it. I was like, you know what, I'm done. So there's 2 options. I either stop this line of research or I switch methods. And I know people would ask, why don't you switch to EEG? I was like, but I was really looking for SDG, right? Remember, my PhD advisor said SDG is universally active for phonology. And John Gabriel said it's universally inactive for dyslexia. So I had to get a shovel and get exactly to that spot. So FNIRS was the only way I was going to be looking at this problem. And so we put a lot of work into fMRI FNIRS co-localizations to make sure that our probe set is exactly where it needs to be for the kinds of questions that we ask. So we're happy with it, we're rolling. And we're looking at parts of the brain that would support meaning and phonology, broadly speaking, to see how that's modified by the different languages. All right, so you guys are neuroimaging crowd, so I'm just gonna go forth and show you some brain pictures. This is English. These are our bilingual kids, and they're doing the English phonology, the cat, king, puppy situation. So it's canonical, no surprises. We've got SDG at dorsal FG. Here's the phonological network. Nobody should be surprised. We were not very pleased. It confirms what we'll expect. Here's morphology. We weren't sure entirely what to expect with the first people doing this at the time. And so, okay, well, we've got dorsal FG, which is phonology, and the ventral, which is meaning. We've got MTG, which is meaning. Okay, looking pretty good. Makes sense. Here's Chinese. Here's Chinese phonology. Doesn't look the same, does it? And they're auditory, they're not reading. There's a reason that it's auditory because the kids can't read in Chinese very well. So we wanted to match for modalities. Here they are. I know you're all very sophisticated neuroimagers. It's just most of you are, right? Which of these 2 has more blobs? Phonology or morphology? Right? So morphology has more blobs. How about this one in Chinese? Which one has more blobs? right? This one has more blobs. So I just told you, right, that this is what predicts reading for these kids. This is how orthography is built. This is how you take the word, segment the word, map it onto units. It's at this level. It's phonology for English and it's morphology Chinese. This is where they're getting their training, right? This is intuitive to the language. This is where the training is happening. Now, morphology, it does, I just argued that emerges early, but it really ramps up towards late elementary and middle school, right? So this is where the kids are struggling, their performance is lower, and this is where the brain work is happening, where this is more automated. This doesn't look, right? There's a lot happening. So you have to understand heritage language context, 2 hours a week, and lots of parents are opted out of pinyin, so they're not even getting the phonetic support, right? So this is where the kids are struggling the most. They're not used to segmenting Chinese words into phonemes. So this is where we're getting into, yes, these are, and they should be transferring, and we have evidence that they transfer between English and Chinese, but not to that extent to completely equate them. So orthography matters, and how you're learning to read in that orthography also matters. The orthography, right? This is the crux. This is the key element, right? Phonology here, morphology here. So that's gaining on automaticity, and this is still developing, and this one's really still developing. So, and these are kids. They're the same children. This is a within-child comparison, right? So, not showing you different kids. So, what's central to the language task, to the task that's central to the language gives you less brain activity, and less brain activity comes with greater proficiency. So here's some brain pictures for brain behavior correlation. So for English, the better the kids know this modality, phonological awareness and morphological awareness, the lower is the correlation. It's a bit of a mess in Chinese. It's all over the place because it's heritage language, so there's massive variability. So, and here's the really pleasing outcome. Here's the SDG, right? This is why I said I was digging for it, right? From those days. There it is. And so this is the SDG. So this is the task that matters most. And this is the segmentation. And this is the part of the brain that's driving that segmentation, no matter, right, how it looks on the surface, as you would call it. We had to dug down to the source of it. So far, so good, hopefully. All right. Ready for question 2? Because this is within language, right? But now we're going to go to cross-language. Cross-language. Some of you might know that derivational affixes and prefixes, right? So this is unlikely, on is a meaningless morpheme that won't stand on its own. You have to attach it to something before it gains meaning, right? That's what derivational morphology means. And it's much more productive and much more prevalent and much more obvious in its meaning in Spanish than it is in English for a variety of reasons. And it's the opposite in Chinese, right? So in Chinese, we just talked about things that compound. They're sort of like apple trees and bread trees. So this is Spanish, and that's Chinese, and we're looking at how these may be transferred across languages. So this time, adding to our Chinese speakers, we're also adding Spanish speakers, and our imaging task included both compounds and derivational morphemes, so classroom, bedroom, mushroom, finger, dance, and finger, right? So you have phonological destructor there. And here's what happens. This is behavioral data. So word reading, morphological awareness for compounds and derived equally predicts word reading for our age group, right? So both matter, and it's really important. Here's English and Spanish. Here's what you need to know about this. Is whatever is not a key characteristic of the language is what's driving the correlation. So compound morphology exists in Spanish, but really isn't as prominent as it is in English, and it's the opposite for Chinese. Chinese does have derivational morphology, but it's not as prevalent. So the feature that is least prevalent in the heritage language predicts English morphology as measured in English the most. Sorry, English word reading measured as measured in English. Yes, go ahead.
What is means?
Word reading. This is Woodcock-Johnson letter word ID task. So it's not timed. Yes. So this is word letter word ID. They're doing this in English. And what we're finding is their proficiency, as we measure their morphological awareness, their proficiency across these features of morphology differentially predicts English word reading, depending on what's their heritage language, right? So proficiency with dissimilar features predicts English word reading. One step further, we do whole brain correlation. So we have Spanish bilinguals and we have Chinese bilinguals, and we're only looking at their English, right? And so we're doing a correlation between their heritage language proficiency as measured with vocabulary and their brain activity during the two morphology conditions. And what we find is that children who are more proficient in Spanish, when they do morphological awareness task in English, they show most activation during compound morphology in English. Kids who are more proficient in Chinese as their heritage language show more STG activation when they process derivational morphology in English. So our behavioral and the imaging data match. And these are whole brain correlations. This is not ROI. So all the channels are thrown in, and it's a really nice convergence. So the way you would want to, right, and it matches the behavioral data. So the way you want to think about this is that the child who knows Chinese, right, the parents speak to them at home, make them do the homework. I heard kids really don't enjoy doing additional homework. So they make them do this additional homework in their heritage language. And because they're good at that heritage language, now they have a conflict with English, right? Because if I don't speak Chinese, and so my brain doesn't have a conflict with Chinese, right? But if I speak Chinese, my English would be in conflict with Chinese, and the brain has to resolve that conflict. And so the SCG, again, helps the part of the brain that we think plays critical role in helping kids segment the words, is helping them resolve that conflict. Because when we think about bilingualism, we often think, oh, there's an L1 and an L2, and so the information is kind of churned through L1. As you can hear my accent, my Russian accent when I speak, that's what it is. So I came to Canada when I was 19, right? And before then I was a Russian speaker. So you can hear my Russian phonology, right, guiding my English pronunciation. For kids who are heritage speakers, you really don't have an L1 and L2 in a clearly defined way. You have an language A and language B, and they might change. Noah is nodding. She's got some heritage language kids at home. So, right, so the two systems are together. They're cohabiting. They're influencing. There's a right tug of war within. And so they're influencing. Elizabeth Bates back in 1994 called it an amalgamated system. We don't like using this term anymore, but it conveys accurately the sense that the languages are in a very close cooperation with each other. And before I move on off of this particular topic, I wanted to show you that something my students really wanted to do is what they did is they did functional connectivity analysis. They were really looking for these bilingual advantage effects, and they found them. So pleased. So what they did is they did gimme functional connectivity analysis, looking again at the kids' morphology data. And what they had found is that in general, taken across all three of our participant groups, monolingual English speakers, bilingual Chinese English, and Spanish English, take across all kids, the better they read, the stronger is their functional connectivity per language. That makes a lot of sense. And then when they split them back up into language groups, they found that the kids who had better heritage language proficiency had stronger functional connectivity when measured in English, right? So the better the kids know their home language, the stronger are their language networks, and the kids were matched for their English proficiency on the surface, right? So their performances are the same on reading tasks, I should say that, on reading and auditory language tasks. Bilinguals tend to fall behind on vocabulary in English, and that's just the thing. Okay. So we're moving along. Morphological awareness. We think there's universality and plasticity. There are cross-linguistic differences. I just shown you, right? We did the blob counting. At the same time, there's universality into the STG engagement. The words must be segmented no matter what language you happen to be operating with. And potentially that's the driver of reading ability and disability across languages. There is bilingual transfer, right? So the features that are similar get transferred, so you don't put too much effort into it across the two languages. And the features that are different will require more effort on the part of the brain and on the part of the learning system. But that's not a bad thing, because the child who's more proficient in their heritage language appear to have stronger language networks as measured neurologically. So far, so good. Okay. Last topic of the day, I think. Last question of the day. So let's put all of this together, right? We talked about the triangle, the magical triangle, where in learning to read words, kids must connect word sounds, word meanings, and print. We discussed how this is super important for alphabetic readers, and this is super important for Chinese readers. It is kind of universal, but there's different weights on the elements. And so going back to our 3 groups of kids, what we also did with them, so they did our phonology and morphology tasks, and I have our 3 populations. And then we had 2 times at which we measured them. So we measured them about 1.5 years apart. We were going to do both behavioral and imaging, but the second time came during the pandemic, so this was on Zoom. Nevertheless, we're delighted to have our behavioral data. And here's what we'll look for. One second. When you look at bilingualism, anybody here does bilingualism? Okay. Wow. What are you doing in Texas? I'm in Michigan studying bilingualism. Shame on you people. We need to swap. You go there, I go here.
Old people here too.
Like, not in this room. Oh, I guess. Sorry, I guess it was. Bilingualism and aging is a big topic, you know, we should talk. When you do bilingualism research, there's 2 things that people look into. First, they look at direct transfer. It's a very fancy word for correlation, right? So my phonology in English should correlate with my phonology in Russian, and if it does, I'm going to call it direct transfer, right? Okay. And then we have this other thing that we call indirect transfer. And that means that we are looking at long distance relations now, right? We're not looking directly at phonology L1 to phonology L2. Rather, we're looking at, are there group differences? Would kids who speak one language read differently from the kids who read the other language, even though we compare them in the same language? So this is, in our case, we're looking, right? So for direct transfer, looking at associations between heritage language morphology and English morphology, and again, phonology to phonology across the 2 languages of the child. And in the indirect transfer, looking just at English, we're ignoring all the stuff back there, we're just looking at English to see whether kids who are matched for word reading, these groups are matched for word reading proficiency and age, but they are different due to their backgrounds. Does this triangle look different for them? That's our indirect transfer. Okay, now that we're ready with that, we have some terminology. Is there a direct transfer over time? And the answer is, here's what it is. So time 1 phonological awareness in the home language correlates really strongly with the time 2 phonological awareness after you've controlled for English. And it is logical. I mean, I can give you words like blikit, and you can tell me how many sounds in there are, right? Because I can give you words in Russian or in any other language. Most of the time, we can count the sounds and segment it into syllables. These are not very language specific, so this stuff transfers really easily. Makes sense. Here, however, there's no correlation for Chinese, and there's a ton of correlations back. Just talk about elections, right? So there's a heavy shared vocabulary, and there's also very heavy shared morphology. Elements of words are the same, so you would expect it. For Chinese, just to give you an example, I studied Chinese for about 2 years. My progress is abysmal. I apologize. And for the 2 years that I've studied Chinese, I found only 1 word that is shared between Russian and Chinese. And it's cha. And it's borrowed from Indian languages. and I thought I had, you know, maybe I thought because of English and Russian is like 50% of the vocabulary is the same. You take an Indo-European language, once you especially hit a certain point of academic jargon, it's all shared, right? It's all Latin and like underneath is Latin and Greek. And I thought that that's because I didn't study Chinese long enough. But I went to Vanderbilt to visit James Booth, and there was a neurologist from China there at the talk, and she came up to me. This just happened half a year ago. She came up to me and she said, you know, my uncle in China, he was an expert in Russian literature and culture and spent several years living in Moscow and really spoke Russian fluently. And when he came back to China, he said, you know, there's only 1 word that Chinese and Russian have in common. And so I take off my hat for uncle because the master Russian with like 0 homophones, right, is really shared vocabulary. So it is difficult. So I have gained a whole new level of respect for people coming from Asia and having to learn any Indo-European language, Russian or Spanish or English, because that is a really big bridge to cross. That was an aside, but this makes sense that this wouldn't correlate. That's one word, right? It wouldn't correlate. But here we go. All right, so now we're going to take a look at the indirect transfer. Here's what happens. Now, emphasizing, forget what's on this side. Just focus here. This is English. T1 English, phonology, morphology, word reading. The kids at this point are matched for word reading proficiency, and they're also matched here. So they're the same. There's about 60 kids in each bin, Spanish, English, and Chinese. 2 groups of bilinguals and English monolinguals. They're matched identically. And if you just looked at their word reading, you'd say these are the same kids. What happens is that there's stronger association between phonology and word reading in the Spanish speakers, even though we're measuring them in English, not in Spanish. And it's the opposite for Chinese readers. So there's your indirect transfer. So I just told you can't transfer from Chinese because the only word is cha. But because 95% of Chinese vocabulary is morphologically complex, and that morphological complexity drives the segmentation of the words, and it drives the way the kids build meanings and recognize orthography. It's a very salient feature. It's a very salient feature of the spoken language, and it translates to be a very salient feature of reading, even at low reading proficiency levels. And so it transfers, and it makes these kids, when they read in English, even though they read exactly the same way that the monolingual English, Spanish English kids are, to form these really robust associations. And we've now replicated these analysis for vocabulary and for morphology and various elements of the process to show that there's this really potent indirect transfer, which is actually quite heartfelt, because I have now seen more than 100 Asian families. And they always look at me and say, what's the point? I'm teaching my kids Chinese. They find it really hard. They hate all the additional homework. What am I really doing, right? And I can tell them they are, right? So morphological awareness is the later emerging reading skill in English that is a key to sophisticated word reading accuracy, because nobody reads ka'ata, right? We grab whole units. So it's a really sophisticated skill, and it translates well, to support advanced reading skills. So that's really is lovely to see. And this was a surprise finding, by the way, because I wasn't planning on looking at behavioral data thanks to the pandemic. I collected additional behavioral data, so it was a surprise discovery, and we're very pleased with it. So heritage language matters. I hope I convinced you of that. We think that's due to the language structure and the way that they guide children's analytical processes about language. It influences reading in the dominant language of reading instruction, which is English in this country. And it reveals variation in plasticity, right? So it tells you that there are multiple ways to become a successful reader of English. There's different ways of doing this. None of them are necessarily wrong in any sort of shape, at least the ones we're looking at. We got lots more to be done. This is I do this every year. I can update the numbers. If I go on PubMed, if I go on Google Scholar, then it's the same, just the numbers will be widened. So I go to conservative onto PubMed and I type in reading brain. Last time I got 17,000. I just add one word bilingual to it, and then it drops to 332 results, which is really sad considering that we think most of the world speaks more than one language. And then I'll look at the dyslexia brain. It's more constrained field, but a healthy number of about 4,000 papers. It was much less when I got into this field, but I typed in the word bilingual in front of it, and then now there's 36, and my lab may have contributed 1 and 2, and that's it, right? This is really sad. So we're here to stay for a while. We have a lovely colleague now I met him here in Texas, in Austin, 2015. Tylee Chow, who is at the National University of Taiwan. And so together we have an NIH, multi-site NIH grant. They're collecting data in Taiwan with typically developing readers and kids with dyslexia. We use the same methodology and approach. And so if you invite me back in a couple of years, maybe I'll tell you what happened. And with that, I want to thank all of you for coming and all the amazing people who supported us. Thank you so much.
Okay, we have plenty of time for.
We have plenty of time for questions.
All of these kids are bilingual in the United States and learn their language from this heritage school, right?
From parents, right? Parents is their primary source. And so some of them go to heritage school, but it's almost 50% that they don't.
Okay.
I didn't send my own kids to Russian heritage school. I was like, I need to sleep on Saturday morning. Bilingual field PTA.
Like the levels of their proficiency in their heritage language. Is there like a cut point-ish kind of effect where maybe they only have to learn till a certain level? Because they complain a lot. And like I have a friend who learned and their kids hate it. Like they hate going to those schools. They don't really like speaking the heritage language at all. And I really like that you point out, well, there's benefits beyond just being able to communicate with your grandma. But is there a point that they need to?
I should have recorded you. I wouldn't have come out of my mouth what you just said, that the kids really hate it, right? And that's what we discuss in the lab. We don't take it out of the lab. So I'm interested to know that, right, the parents here, they come in and so yes, 100 really sad stories of parents come in, like, we want them to talk to grandparents. We want them to know. I mean, I can say the same thing. I want my kids to know my culture because I want them to understand who I am, right? Because as a person who comes from different cultures, you don't want to be raising aliens. You want to have, right? You want to be able to have a common language, and language is a gateway to culture. And so it's really heartbreaking. And it is and I've come to appreciate how big the distance is with Asian cultures in ways beyond just literature, right? It's the language, it's the whole package. We do not do cutoffs. We haven't looked at cutoffs. We do a full continuum. The biggest battle that we get is that there might be a cutoff and I might not be seeing it because we've had to battle a lot of the times the parents say, oh, I don't want to participate in your study. My child is not bilingual. And we're talking to a household that only speaks Chinese at home, right? But they're like, my child is not bilingual. Right, and so our recruiters, our recruiters are members of the community, and they go to parties and holidays and community events, and they try to get parents. So we try to get as representative sample as possible, including the people who think their child doesn't speak Chinese because they can't write full letters. So I hope that answers. So the correlation here is like. There was no cutoff here. And this is the reason we pick vocabulary. If I were to pick word reading, I'd be getting nothing here,
right? Because
a lot of them are it's so low that the variation statistically makes no sense. So it's a spoken language.
Collaborating Taiwan, are they doing this but reverse, where the target language that they're like, because their primary language would be Mandarin, and then I guess they're
correct.
Yeah.
Correct. So our partners, so the goal of the specific grant was they would just look at monolingual Chinese because it's to understand universality and language specificity and dyslexia. So we have that's their aim. So their site aim is that we have monolingual kids with and without dyslexia, and they have monolingual kids with and without dyslexia. We also get bilingual Chinese-speaking kids. We tend to have difficulty getting bilingual Chinese-speaking kids with dyslexia because then the Asian families really drop Chinese. If you know them, please tell them not to do it. They really just go on and do it, and then they don't usually want to see us, and so that's heartbreaking. But that's sort of the ideal goal, is to again try and get as much variation. But outside these aims, they are looking at bilingual kids as well who are Mandarin dominant and are getting some English in Taiwan. English is a very popular language in Taiwan. So yes, that's the full answer to your question. We have published a paper. They led the effort. So in your image, I think about half a year ago, came out a paper looking at that population in Taiwan, looking at their English and Chinese phonological awareness. Sorry, I think you've had your hand for a while.
Yeah, that's a. I was really struck by the transfer, and I'm curious if you think that it is a developmental specific process that allows for that transfer, or if it's specific to language, or if it's the intersection of both of those things. Because a lot of people here study, trying to do transfer of other cognitive skills, and it's harder in older populations. So I'm just kind of curious what you think, if it's developmental, if it's language specific, or if it's kind of the intersection of both of those things. Does that make sense?
Let me see if my answer makes sense. I don't think we would find these effects in adults, but we are exactly at a spot, kindergarten to grade 3, where the way we measure for knowledge and the way we measure morphology is really rapidly emerging. And so we're catching them with these two measures at the right point in the right time. Adult readers kind of tend to be super morphological, which I was saying, like it really is productive to be morphologically biased this way. As an aside story, it took me almost 5 years to publish this for the first time. I kept getting rejections from journal editors where the letter from the editor would say, this is not true, cannot be, this is not the way English readers should read. There was this very heavy idea that phonology is the only driver, right? And I kept showing that these kids are not dyslexic. By the way, they're not dyslexic, right? I promised to show you some dyslexia data, but I actually haven't. That's for the guys at the IDA. But this is productive for them. So, but that doesn't, some adjustment of I don't know, I'm sorry, past the age of 10 is geriatric. I don't know how you do it, but I'm sure it wasn't clever enough to get to these levels of processing. Maybe you can measure it, and maybe it still makes a difference. So as an anecdote, I would write, so Russian is my primary alphabet. And so when I have to write words like because, and I don't know how to write them, and somebody would ask me, like a Russian speaker would ask me, like, how do you spell because? I go, Ioulia, right? It makes perfect sense, right? There's all this stuff in there. And I can do this with my Spanish and Italian and other alphabetic colleagues. I'd be like, how'd you spell it? Now, like, drop it down on how, like, Latin alphabet pronounces this, like, bypassing English. And I cannot do that with my Chinese-speaking students. They look at me like I'm crazy. So I'm pretty sure they're doing something else, but then all of us are adult L2s, and I'm showing you, baby data. They're kids. They've learned them as really young. So I don't know. If you want to do it, I think you should. I think it's really fascinating. Yeah.
So I kind of have 2 questions. Mm-hmm. So the first one is, all of this is trying to see how complexity in phonological and morphological these systems affect English literacy.
Correct.
Which is, like, at some point, like maybe mid to low orthographic depth. But what happens if they're trying to learn something that's also of high orthographic depth, like a Mandarin speaker? Like I don't have a language, but like a Mandarin speaker trying to learn something that's equally as morphological complex. But it doesn't really rely so much on the phonological. Are you?
Yes. So just first, among alphabetic languages, English is the deepest of them all. So we're in a good spot here. But yes, if you were a Mandarin speaker and you wanted to learn Cantonese, you'd have far easier time doing that than learning English, right? So
they might use different scripts, but they share similar origins. So there are still like similar characters. But what if I'm trying to learn something that's also just as equally deep in its orthography, but it's like, I'm not sure.
I don't think it's about, okay, let me go back. I don't think this is about, I'm not talking about depth of orthography. I'm talking about phonology and morphology. The tasks our children are doing are predominantly auditory, short of one reading. Most of our measures of phonological morphological awareness are auditory because that's where the kids have automaticity for the youngest grades. If I try to do it in visual modality, they just won't manage the task. They'd have to be at the geriatric age over there. So the transfer is within language, right? And so if I am, so it's been shown very, this in adults, right? If you're a second language learner, if you're going from a language that has structure A, and now you're learning a new language that also has structure A, you will have far easier time doing that than learning a language with a structure B, whatever it is, word order, morphological segmentation, there's many parameters by which languages are the same and different, but you'd have far easier time doing that, never mind orthography, right? So we're talking, what I'm arguing here that this whole time is it's actually not about print. It's not about what you see. It's how you segment the words, and the auditory modality, and hence the humanity had evolved. The typical culture that speaks that language had evolved to have that kind of orthography. And I'm going back in that step, saying, okay, whatever is in that spoken language structure, actually, without gaining too much orthography in Chinese, you can still transfer into how you read in English, which is pretty cool. But if it's similar, then yes, of course, it's a half a step as opposed to a full step. Does that make sense? Yes, I hope so. I don't know how else to explain. I mean, it's easier for me to learn Spanish than Chinese, right? This is what I keep saying. It's because Russian is an Indo-European language. And so the way it segments on many, many levels beyond orthography makes it easy.
So of course, my statistical learning developmental brain is going to close. So what I think is really cool about this is fascinating is I'm thinking about our developmental work, right?
Mm-hmm.
Work that Dick Aslan and Katie Graff and we know that if we have artificial languages, we can artificially train whatever meaningful
right
that we want, right?
Right.
And so what I think is really cool about your work is what you're saying is whatever the probabilistic meaningful is, shows up in the reading.
Correct.
Which is really cool because that means that if in terms of so you may end up in the same loop we ran into, which is better statistical learners, have more vocabulary, better word learners, kind of thing. But that means that your statistical, if we were to do some of our statistical learning tasks on you guys, we could probably predict who are the ones who are the better learners of any one of these because they're sensitive to, or they can learn new chunks, but it should be developmental because once you've gotten past a unit, it sort of freezes and then it's, well, let me go back. So like we know in English, for example, we care about the phonological cues because then I can statistically track and discover word boundaries if that's the meaningful unit in that language, right?
Right.
Okay, so we look at the babbling data, workers, all that group, like 8 months kind of thing, right? So what that means though is in other languages, it's a larger morpheme unit chunk is going to be the meaningful statistic. But once you've got that statistic sort of in your filter, that then becomes your filter for the next phase in development, right? So then you get the baby phenomenon, right? Where the kids now begin to hear, but that unit chunk then filters the next segment, right? And so once you've sort of got that chunk in your brain, it acts as a filter to make you more efficient in the next unit, right? So this means you should be able, right, to do some unit size, right? Right?
I've been missing it for 15 years of my life.
Oh.
Because the person I work with, I feel like Twyla Tardif who set me on this path. I was like, I don't know enough Chinese that I cannot reason for it. I mean, I know enough English, but I don't have that level of understanding of word processing. Because my argument is it has nothing to do with orthography. It has everything to do with language structure. But I don't understand enough about that level which you have just described to test that as a hypothesis. In every paper I write at the end, in my conclusions, I always say, it is not about print, it's about speech, and it's something about word, and somebody who studies toddlers should do it.
7 to 9 months, we should be able to bring in, right? We should pick up the unit like Janet Worker's work, right?
Right.
Pick it 7 to 8 months, they won't care. They're perfectly happy with any combo of whatever. And then whether you're tuning to what we might call a morphology chunk, it's just the size of the chunk that they are tracking in their input.
I don't know what it is. So, right. So the thing is that, sorry, one sec. So this is the fascinating part to me is that in an Indo-European language, we have 17,000 possible syllables, right?
I'm not talking syllable.
Oh, you don't, you
No, it's whatever.
So you think it's the segmentation?
No, it's
But
the
is it-
acoustical meaningful unit of whatever the language is, that's the probabilistic statistic. So in our language, English, it's phoneme level, but it would mean that in Chinese, it's gonna be a bigger.
Chunk because there's less of them, and so it's more combinatorial, right? We combine the bejesus out of phonemes, which is Chinese combines the bejesus out of syllables.
And is there a way to map those and to try to see where the similarity, kind of almost now thinking about transfer, and if so, then the learning might be able to do this, take it out of the critical period and make it different.
Yeah, because we could build the languages where you artificially.
Right, because this is what we've been, again, I say this in my discussions because I have no proof for it. We just say, okay, if you have English and Chinese, right, these are your 50-50, but this is your full 100. But your statistic, right, your statistic of Chinese has really shifted the way you're analyzing spoken word. Now it's on my spoken word tasks at age 6 are playing different role for the way you read words in English. So this is what I've been arguing for like the last decade with like zero proof for it, just like a hunch. Thank you. We should keep this conversation. I'm sorry, everybody. We just
Yes, because I was thinking about something related. So the other half of the worker argument or worker descriptions is production of language, right?
Yes.
So everything you've shown here has been reception.
Correct.
Have you looked at just whether or not people, the way they speak or what they write differs?
Or even in the babbling, right? If we
Sure,
really,
the
we should
babbling,
see it coming in earlier in the babbling, right? Because that's when the babbling shifts right about the same time, and it should be at this unit size.
So my thought though is
science.
would be that, what I would was going to ask, but it's like it still may be something developmental that happens much later. It's a very different mechanism, but it from my personal experience, the 2 hours or an hour, 2 hours a week amounts to very little in terms of my kids being able to pick up Chinese. It's the consistency in the schooling when they started offering it in middle school that allowed things to click. So it's a very different mechanism.
Well, and we know that it's also not only timing, but there's a trade-off between the complexity of the statistics and the amount of time, like, because we can teach babies in 10 minutes.
Yeah.
Okay. But they also don't already have any pre-existing filters, right? Yeah. So we got to figure the age and the complexity should then be a linear of the probability of the time to track the statistics.
And whether it goes on the same mechanism, it might.
Or might not. It might be a different one at a different age.
Babies are different. So babies are more monolingual, right? So in our samples, because it's usually the two parents, right, and they speak the same language, and the grandma, right, and by then we see them, they're dominant in English, but they had reached balance and switched at some point between like ages, probably like for our bilingual Chinese speakers, like somewhere between 3 and 5, this has happened. They entered the kindergarten and they had switched that. So Janet Worker I have a postdoc, and my former student is doing postdoc in Janet's lab, and that's what she's complaining about, is that their babies and their from Asian families are usually monolingual until they had gone to the daycare, and then they're beginning to become bilingual. So it'll be a trick, unless you found like a 50, right, a parent, right? So you really have to look for couples where there's another.
You can test these in our.
Everybody can leave now. I'm so sorry. We're designing a study.
Yeah.
Later, but yeah.
Right.
Is there any, and we also checked for, is there any questions online?
I don't know how to.
Do we have any questions online? If anyone's still there?
No.
Okay. Okay.
I'm gonna be looking at the roster, but I'm not a turn on English.
Okay, well, Ioulia's here at CBL for the day.
The end of Saturday. Okay, so wanted to come downtown. I don't know where it is, Hyatt Regency. I don't know.
That's here.
I think it's somewhere.
But let's please join me and give one more round.
Thank you. See you again.